This is Dr. D. Gokila. In this video, I am going to explain the rapid application model. The rapid application model consists of 4 different phases: requirement planning phase, user description phase, construction phase, cutover phase. Requirement planning phase is a workshop utilizing structured discussion of the business problem. It is automated tools capture information from the users. The construction phase, productivity tools such as code generations, screen generators, etc. The time box. Cutover phase is an installation of the system, user acceptance testing and user training. The RAD strengths are used in such a way that it reduces the cycle time and improved productivity with fewer low people means lower cost. Time box approaches mitigates cost and schedule risk. Customer involved throughout the complete cycle minimizes of the not achieving customer satisfaction and business needs. Focuses moves from the documentations to the code, uses modeling concepts to capture the information about the business data and also the processes. The weakness of RAD are used in such a way that the accelerated development process must give quick responses to the user, risk of never achieving the closure, hard to use the legacy systems, requires the systems with hard modularized data, developers use the customized commitments to rapid fire activities in an abbreviated time. So using of RAD is reasonably a well-known requirements. User involves throughout the life cycle. Project can be time boxed. Functionally can be delivered within increments. High performance not required. Low technical risk. System must be modularized. The incremental SDLC model are used in such a way that construct a partial implementation of the total system. This slowly add increased functionality. The incremental model prioritizes the requirements of the system and then implements them to the groups. Each subsequent release of the system adds functions to the previous relay until all designed functionality has been implemented. Develop high risk or major functions first. Each delivers an operational product. Customer can respond to each build. Uses a divide and conquer technique, breakdown of task. Lowers the initially delivered cost. Initial delivered product is faster. Customers get important functionality early. Risk of changing requirements is reduced. And also incremental model weakness are used in such a way that the incremental model are used in such a way that it is used for good planning and designing. When to use the incremental model? Risk funding schedule, problem complexity and the need for the early realization of the benefits and the most important requirements are being fulfilled but are expected to evolve over time. And need to get basic functionality to market requirements in such a way that the projects are lengthily developed schedules and the project have a new technology too. This is a spiral SDLC model that adds risk and 4JL RAD prototyping to the waterfall model. Each cycle involves the same sequence of steps as the waterfall model rise. So determines objectives, alternatives and constraints, objectives, functionalities, performance, hardware and software interfaces, critical success factors, etc. The alternatives are building, reused, buy, subcontract, etc. The constraints are cost, schedule, interface, etc. So evaluate alternatives, identifies and resolve risks. The alternative related to the objectives and constraints, lack of experiences, new technology, tight schedules and poor processes, etc. Evaluate if money could be lost at continuing the system development. The spiral quadrant are used in creating a design, reviewing a design, developing a code, inspecting a code and testing the product. Develop project plan, develop configuration management plan, develop a test plan, develop a installation plan. It provides early indications of surmountable risk without much cost. Users see the system early because the rapid prototyping tools, critical high-tech functions are developed first. The designs does not been perfect. Users can be closely tied to all life cycle steps. Early and frequent feedbacks from the users. Cumulative cost assets frequently. The spiral model weakness can be evaluating risk too large for small and raw projects. Time spent planning, resetting objectives, doing risk analysis and prototyping may be also excessive. The model is very complex and the risk assessment expertise is required. Spiral may continuously indefinitely cause the developers and reassigned during the non-development phase activities. May also be hard to define objectives and verifiable milestones that indicates readiness to proceed the next iteration. When the spiral model is used, we have to make sure that it creates prototype with appropriate data and risk evaluation, and it is used for ensuring the needs, product lines and significant changes are also expected. And also next to the topic is agile. This is very important. Agile is used for speeding up the bypass and life cycle phases, usually less formal and reduced scope, used for time critical applications, used in organizations that employ disciplined methods. Agile methods are ASD, FDD and DSDM, RAD, XP and RUP. So this is the last, which is very important, which is extreme programming for small medium sized programs with a vague rapidly changing environment. The coding is the very key factor for this software project. Communication among the teammates is done with this code. Life cycle and behavior of the complex projects is defined in test cases against code. The XP practices includes planning game, small releases, metaphor, simple design, testing, refactoring. So the pairing game, collective ownership, continuous integration, 40-hour week, on-site customer and coding standards are also used. When we take XP is very extreme, the code reviews are good. Review code are all-time programming. Testing is good. Everybody will test at the same time. If the simplicity is good, keep the system in the simplest design that supports the current functionality. The design is good. Everybody will design it daily, and the architecture is very important. It will take a defining and refining at the architecture. The integration testing is important. Build and integrate testing several times a day. If short iterations are good, make iterations really short than weeks. So this is some of the online references that is used for XP programming references. With that, extreme programming, XP references are all over. Thank you for listening the video. Thank you, students.